Okay, so this is a real pleasure today. This is going to be fascinating today. The title of our talk today, right, is The Call of Antarctica with Leilani, Raashida Henry, and Ted Scambos. Now, just a little background. Leilani and Ted are going to recount the history of one of the early explorations to the continent by following Leilani's father, okay, George W. Gibbs Jr. of Richard Byrd's third expedition. I think Richard Byrd, that's a name that I think all of us remember as a great early explorer. And it's going to be following her story that her father was the first Black man to set foot on the Antarctic continent all that many years ago. So this fascinating history, I think. Now, just a little bit of background. Leilani Henry, she's the author of The Call of Antarctica, Exploring and Protecting Earth's coldest climate. She's the founder of Being and Living Enterprises, a consultant for the International Thwaites Glacier collaboration, and a demonstrated thought leader in organizational learning. Of course, we all know about the Thwaites Glacier here at NSIDC because it is one of the things that we really study, and Ted is leading that effort. Now, I think you also know Ted. Ted is a Antarctic glaciologist extraordinaire, been to the far reaches of the continent. And I believe, Ted, that you've been beyond the ice wall that the flat earthers claim marks the edge of the planet.
Yes. Right? Yeah, I've been around the backside and came back to the front. Yeah. I've actually gone around the world the dumb way. Not to the North Pole, but yeah, as sort of South Pole and then up through South Africa. And yeah, it's all round as far as I can tell. It's a sphere, pretty much guaranteed.
Well, there you go. So without further ado, Leilani and Ted, you have the podium.
Thanks, Mark.
Why don't we, bring up the first slide.
Okay.
Great. Well, quick further introduction. A lot of you might be wondering how Leilani and I came to meet. We were both working, as it happened, on aspects of Richard Byrd's Little America 3. It's actually called the Antarctic Service Expedition to Antarctica. One of the things they built there was the base called Little America 3. And at that base, there was a huge vehicle called the Snow Cruiser. And I was really curious about where that might be found nowadays. And while working on that, Leilani and I met at a meeting of the American Polar Society. I think it was 2010. And she was explaining her father's diaries, and she was still sort of internally wrestling with the idea of writing a book based on her father's diaries. And of course, over the years, she followed through on that, and I was happy to help her on some of the Antarctic details. And it's been wonderful teamwork since then. Leilani is also helping with the Thwaites project on our DEI efforts and also on the team health for the field teams that go into Antarctica. And we'll talk a little bit about that at the end. There's a great poem here on the front screen by Robert Frost that I think really resonates with anybody who's been to Antarctica, because the power of cold weather and ice is awesome and somewhat scary sometimes. And Robert Frost captured it well. Do I advance the slides, or do I say advance the slides? So Leilani is going to talk about Antarctica. We're going to talk about the Little America 3 expedition, or the Antarctic Service Expedition, which started from, Boston, and sailed into the Ross Sea, set up Little America, pretty much at just above the word Ross, in Ross Sea on that map on the right, and then sailed somewhat circuitously around to the area in front of Thwaites Glacier, and they actually discovered that coastline. We'll talk about that, and then built a second base on the peninsula. Everybody has a useful map of Antarctica in the palm of their hand. If you just stick your thumb out like you're hitchhiking and curl your fingers around, it helps a lot in meetings or talks where you don't have a nice map to show on the screen to point out where you've been or what's happening where in Antarctica. There aren't many other continents you can do that with one hand, sort of do a South America. That's about it. Europe, I think you have to break your fingers and rearrange them and stuff. So with that, please take it away, Leilani, and we'll go through the history and then some of the science for West Antarctica.
All right, I have to start over again with just the basic. All right, so I also wanted to say that in 2010, when I was explaining my father's diaries and trying to figure out what kind of book to write, it could have been a biography, it could have been creative nonfiction, it could have been fiction. So I'm happy to say that the book landed on a combination of science and history and culture and my father's diaries. So the first thing we want to just make sure you know is what was the last coastline discovered on Antarctica. And I had a lot of fun. When I first started this, I knew nothing about Antarctica, nor did I know anything about my father's expedition, because he was an older father, same age pretty much as my grandmother, my maternal grandmother. So, you know, we thought that what he was doing wasn't that important. And then when we found the diaries, then I found out how important it was. So we think about James Cook, which everybody's heard of, who went as farther south as possible during that time in 1774, and realized that he just didn't think that anyone else would ever go again, and it was a horrible place. And then 166 years later, my father wrote in his diary that Byrd was wanting to beat the record of James Cook, and in fact did that. And my father was on board and talked about that on that day, what happened. So this is the ship, the USS Bear, which is probably one of the most famous ships in for the US and maybe even the world. And Admiral Byrd, it was his favorite ship, and he took it on his first 2 expeditions. And then it was in a museum near Oakland, California. And when the 3rd expedition started, Roosevelt wanted to partner with Byrd in order to make it a more successful expedition and perhaps see what the Germans were doing in 1938 as well down on the continent. So Admiral Byrd bought the ship for $2 and put it back into commission. And at that time, it was 66 years old, an old wooden ship. And then on the ship, there was also the Barclay Grow, which was a plane that was the one who discovered the last coastline on Earth, which is the Walgreen Coast. And here is the crew. There were altogether about 80 dogs and 125 men on 2 ships. My father's here. He was not the only Black man aboard the ship. There were 2 others, but one went only 1 round trip, and the rest of them went 2 round trips. So this man is David Taylor. So here's the path of the bear, and they landed here on the West Base first, and established that base under the ice. I have a picture of that. And then got back on the ship and found was not a smooth trip. They got stuck in the ice probably 3 times, and they couldn't find where they wanted to start the east base. So this is where they ended up landing. And it was getting close to the time when they would have frozen in for the winter. So the second ship, the North Star, went back to South America to pick up supplies in the event that they were going to be frozen for another year. And then here's the Walgreen Coast, named after Charles Walgreen, who founded the Walgreens that's still around today. And then the Thwaites Glacier is here as well. So this silent film I found in the National Archives. And so they sailed, this is the North Star, people on the North Star taking this video. And this is George W. Gibbs Jr., who got permission to be the first man off the ship. And in doing so, became the first Black man in the world to set foot on Antarctica. Let's see. All right. So as Ted said at the beginning, this is kind of what brought us together, because I was just learning about the snow cruiser, and he knew all about it. And the other interesting thing for me is that in my research, I researched, little embarrassingly so, 20 years off and on. I gave up several times. I didn't want to be a starving artist. It was hard to write a book and be an entrepreneur. I was also frustrated because I couldn't find a lot of the information. And then I realized, or I found out, that it was a classified mission, and that's why it wasn't in a lot of the books that I was reading. And in the research that I did find, everything was in black and white. I had no idea of the colors that were down on the ice. So when I saw the red plane and the red snow cruiser, I was completely shocked. So the other thing about this is that America has always dragged feet a little bit on Antarctica. And so there was all kinds of all other countries were getting down there and establishing, and the United States hadn't done that. So this expedition was the first that the United States was involved in 100 years. And then the bases we talked about. And then Little America, you might have, because we're in Colorado, you might know about Little America gas station, that's Sinclair, the Sinclair brand. And Sinclair was one of the donors for the expedition. Byrd was very good at getting money from corporations, and Sinclair was one of them. And so there's a connection there with the name. It was very successful, as some of you know from history. Many people died on other expeditions over the years. No one died here. And science, as Byrd was always focused on, they discovered mountain ranges and islands and 150,000 square miles of unknown land, which included the new coastline, which is now the Walgreen Coast and includes Thwaites. One of the other challenges I had was to type my father's handwriting. And I'm lucky that I was able to read it, but it was very flowery. And because I didn't know about Antarctica, there are a lot of things I had to try to decipher. And then that's the cover of my book. And then this page, again, you can see the handwriting, does say that Admiral Byrd made the trip this time, on this day, and he was just getting over being sick. And I don't know if you can find this anywhere in the world that you would know that Admiral Byrd actually was ill as he made this discovery. The other fun thing to know about is that in my research, there were people, I wrote an article in the American Polar Times and got a lot of phone calls. And one of them was James Richardson, the son of Jack Richardson, who invited me to their home to look at his father's artifacts. And at the time, again, I knew nothing about the expedition, and we discovered the picture of my father. We discovered that they were friends because they were among the youngest on the trip, and they were scraping paint off the bear, trying to get the bear ready. And they remained friends. And Richardson was one that stayed on the ice, and my father was a mess attendant, the lowest rank on the ship. So, you know, they could have been unlikely friends. I also found out later my father was a great photographer, and these were the ones that he was able to use the darkroom and get photos. He had to turn in all the negatives the Navy demanded because it was a classified mission. So he had over 200 negatives that were given back to the Navy. So I don't know where those are, but the pictures that he developed, he was able to keep, or he did keep. And then this is Little America at West Base, Little America 3. So as you can see, you're going down into the ice to live there. There were tunnels, there was places for the dogs. There was a ice palace where you could get stuck on the toilet if you weren't careful, and you would be handed a hot water bottle in order to dislodge yourself from the toilet. And you know, when I was in 4th grade, that was what I remembered about the expedition. And then this is the East Base. This is a photo that Ted took. This is a museum now. Very interesting to know that the building is still standing. And it was obviously covered with snow like the other base when they were living there. All right, and this is Thwaites Glacier.
Yeah.
And that's going to give you some science.
Yeah, so let's spool forward to 2019, 2020 actually. We're arriving at Thwaites Glacier. That picture is of the very central portion. If we could go back one slide, the very central portion of Thwaites Glacier. But in fact, the fast flow extends all the way to the horizon that you can see here. And in fact, out of the page over your shoulder, it extends for another 30 or 40 miles. Thwaites Glacier is the widest glacier on Earth, about 70 miles wide at its outflow point. And it drains an area as large as the island of Britain. The US state that is most similar in size is Florida, but in fact, I kind of like to use the state of Georgia because it's similar in shape to Georgia in that it has a broad coastline, but it extends even wider into the interior of the continent. So larger than Georgia, kind of shaped like Georgia. You'll see a map in a second. And you can imagine that if there's a mile thick of ice over an area the size of a US state, a medium-sized US state, and you were to plop that into the ocean, you could expect that the bathtub would fill up a little bit. And that's exactly what we're worried about, is the potential for sea level rise from Thwaites Glacier. Using remote sensing, it's easy to identify areas in Antarctica now, in particular ISAT-2 data. This is from a paper by Ben Smith using both ISAT and ISAT-2 data, both of which are archived at NSIDC. They looked at the difference between the elevation maps generated from those two satellites and identified areas that were changing rapidly. And the largest red blob there to the slightly lower left is the basin that includes Thwaites Glacier. At the center of that red blob is Thwaites. It's unloading about 50 to 60 billion tons of ice more per year than is falling on the surface as snowfall each year. And it's it has the most upward potential for further increase in flow speed and increase in net delivery of ice into the ocean. So it's of great concern. And because of that, the International Thwaites Glacier collaboration was formed, collaboration between the US and the UK. Talk more about that in just a minute, to study the area. So if you remove the ice from West Antarctica, you can see what the problem is. Thwaites has a very wide, slightly higher line of mountains underneath the ocean, all below sea level, and yet the land rises just a little bit as you get towards what's currently the coast or the grounding line for Thwaites. If you retreat from that line of hills just below the word Thwaites in this picture, you get into much deeper bedrock, and the ice is piled up even higher on top of that deep bedrock. That creates a situation where you can get a runaway outflow of the ice if the ice begins to retreat from the current grounding line, from the current what you might call coastline. Because as you retreat inward, the ice gets both the base of the ice gets deeper and the top of the ice gets higher. So the vertical column is quite tall as you step backwards from that coastline. Ice is driven by that weight of ice that's attempting to squeeze the mass of ice that forms Thwaites out, kind of like stepping on a tube of toothpaste. And if you continue to retreat, you get a faster and faster outflow across this very broad outlet for Thwaites. And that's the threat, that models suggest that within a century or two, we could see a rapid runaway of ice flow out of Thwaites Glacier. And eventually, the loss of Thwaites Glacier would take the rest of West Antarctica with it, because it's in kind of a keystone position within the center of that ice sheet, and would draw the other glacier basins in with it and out through the same wide outlet that Thwaites has. These two areas, the Thwaites Glacier is being affected by changes in the winds around Antarctica. I said two areas because Larsen B, another area of rapid change in the global warming area, is also being affected by these wind changes. Focusing on Thwaites, what's happening is that the west winds that blow completely around Antarctica, the large blue arrows that you can see here, have been picking up in speed. This is related to the ozone hole, which has a fairly strong seasonal effect on increasing the westerlies, but also has to do with global warming and the fact that the tropics, the entire tropical band, is getting warmer. Because Antarctica, being a large ice sheet, it actually sticks up into the atmosphere. And so there's a tendency for storms to go around rather than over the top. As the tropical latitudes of the Earth have gotten warmer, these westerly winds have picked up speed rather than distributing or changing course over Antarctica. Antarctica is occupying the South Pole area, so the westerlies are picking up speed, encircling Antarctica. Those westerly winds tend to push the surface water to the left in the southern hemisphere. That's an effect of the Coriolis force. It's also called Ekman turning in oceanography. By pushing the surface water away from the coastline, there are areas where deeper, warmer water is induced to come up onto the continental shelf and then approach the actual floating edge of the ice sheet at depth. So several hundred meters below the surface, we're seeing an increasing amount of, in oceanographic terms, warm water. You wouldn't want to swim in it. It's only 2 or 3 degrees above freezing, yet it still contains enough heat to do a tremendous amount of melting if it encounters the Antarctic ice sheet at depth. And that's exactly what's happening in Pine Island and in Thwaites Glacier. Because of this instability that I mentioned before, you retreat from the coastal edge and you get faster and faster flow. The IPCC added a line to the estimates of sea level rise for the coming century, a dashed line. They said it was low confidence in exactly how much additional ice might be added to the ocean as a result of this instability. It's called the marine ice sheet instability. But it's a fairly scary line, because in the warmest scenario for the IPCC's modeling, it added nearly a meter more sea level rise between now and the year 2100. I should point out that any one of those less intense warming episodes may still have to contend with an increased amount of ice flow out of Thwaites Glacier, because this instability may already have been triggered. Models show that it's likely that we don't have to do anything further to see the West Antarctic ice sheet eventually collapse. However, those models also show that if we reduce greenhouse gases, the effect of these changes in the surface winds based on changes in the Pacific especially the tropical band, but the Central Pacific in particular, that we can slow down this process so that the rise in sea level rate from West Antarctica is more manageable for coastal infrastructure. And that's the key, is that managing this at a rate that allows us to preserve as much infrastructure as possible around the world's coastlines is critical. That's why there's still a strong motivation for addressing greenhouse gases and addressing the threat from Thwaites. Sea level rise has done this kind of sea level rise rate before in the recent past. At the end of the last ice age, we saw periods of time where we had sea level rise of 4 to 6 meters within a century, or 4 centimeters to 6 centimeters within a year, because large ice sheets were decaying away. And in particular, the marine ice sheets in what's now the Barents Sea and the last part of the Laurentide ice sheet, the decay of those large ice masses led to incredibly rapid sea level rise rates, rates that would be totally unsustainable in terms of our coastal infrastructure. And you can see that in the last 6,000 years or so, we've had an incredibly stable period in terms of sea level rise. So naturally, we've put a lot of infrastructure near the coastline because it's an important place for commerce, a place for people to work and live. And that is now threatened if we see a steep increase in the coming century in sea level rise. The International Thwaites Glacier Collaboration was formed. It's mostly a collaboration between the US and the UK, but strong partnerships with South Korea, Sweden, and Germany, assisting in the effort to explore every aspect of Thwaites Glacier and the adjacent ocean, the Amundsen Sea embayment. If you go to the next slide, this is sort of a summary of both the processes that are going on at Thwaites Glacier and the Amundsen Sea, and the scientific instrumentation that we have, in fact, deployed. We finished our last field season this last February, have in fact deployed on Thwaites Glacier and collected a tremendous amount of data, both on the surface of the ice sheet, at the edges of the glacier where it's shearing past ice that's not moving quickly, further upstream along the center line of the glacier, looking at the sediments and rock outcrops beneath the ice and beneath the ice shelf. One of the hardest places to reach on Earth is the water below a floating ice shelf in Antarctica, and we've used automated vehicles to explore that area, as well as moorings that rest on the ice shelf and measure the ocean conditions from a fixed point for a longer period of time. And a whole number of surface stations measuring weather and GPS and ice thickening and thinning. APRES stands for ice thickening and thinning, automatic phase sensitive radio echo sounder. On the processes, I talked about how warm water off the coast, you can see those red layers, CDW, it stands for circumpolar deep water. It's always been there, but with this change in wind patterns, it's being drawn upward and spills over the continental shelf edge and then flows to this point where the ice first lifts off the grounding line. That's on the left side of the diagram where it says basal melt and grounding zone. And that's the area of critical activity on Thwaites, is that increased melting right at the point where it goes afloat. That's leading to the faster flow and leading to this potential runaway situation. The other possibility, and I don't see it on this graphic, it must be on the one that talked more about processes, is ice cliff failure. If we get a very tall ice cliff on Thwaites, we may see a runaway in terms of fracturing and collapse, which would accelerate the loss of the ice into the ocean. But in fact, modeling of that process has reduced the likelihood of it being sustained for a long period of time. Okay, next slide. It was really difficult to get to Thwaites, although you might think that being due south of California, it wouldn't be all that tough to get to. But in fact, there are no bases along that section of coast. And indeed, it was the last section, major section of coastline in Antarctica to be discovered. And Byrd took the first photographs of that in February of 1940. we had to use all the resources we could get, both the UK and the US, to put people out in that area. The ship, the Nathaniel B. Palmer, visited the area 3 different times to put people on land near that coastline so we could measure the ice. We needed to set up a base called the West Antarctic Ice Sheet Divide Base. We reopened that camp from an ice coring effort that was over a decade ago. And then using all of those aircraft, the 2 aircraft that you see on the upper right, to put up to 50 people out on Thwaites Glacier for an entire field season. There were a lot of delays. NSF struggled mightily to put this kind of an effort, this scale of an effort so far from McMurdo, but over the course of 5 field seasons, we were able to collect nearly all of the data that we intended to collect for those different groups. And here you can sort of see all of those words are acronyms. I won't go into them, but they identify what parts of the glacier they were focused on. I was heavily involved with the landward side of the Tarzan project, which you can see there on the left side. The most recent ones to finish were Time and Ghost. I mentioned that Time was studying the shear margin of the glacier, where it butts up against ice that's not moving so quickly, and then Ghost, which looked at the bedrock below the ice using seismic and radar instruments. This is Thwaites Glacier in action through a radar time-lapse showing the outflow of the glacier and showing that part of it is currently blocked by an ice shelf that's slower moving, somewhat smooth. Oh, I guess that's a trapezoid sort of shape in the rifts and ridges that has not yet completely broken out, but it is on the way out. There was a lot of concern initially that when we lost that slower moving, somewhat smoother surfaced area of ice, that Thwaites' fastest flow, all of that is Thwaites that you're looking at, but that the fastest flow would expand dramatically into that area that's not moving so quickly. That turns out not to be the case, again, because of those low hills in the bedrock right along that red line where the ice begins to go afloat. And so now the loss of the ice shelf will probably lead to about a 10% increase in outflow, but not a doubling or tripling as we initially feared. We've understood much better what the oceanography is like underneath this area. That smooth area I was talking about is called the Eastern Ice Shelf. You can see we've identified more how the warm water at depth gets into the cavity underneath the ocean cavity, underneath this floating ice and up to the floating edge of the glacier, and also how the outflow with increased meltwater leaves the area. This is one of the first major results of the project. We also investigated this ice cliff process in detail. And what you're seeing here are several experiments, a summary of several numerical experiments that were run with different ice thicknesses, different flow speeds, and different depths of the water sort of surrounding the ice and trying to, in some cases, lift it off of the bed. And if we go to the next slide and run these 2 models, you can see that there are very different styles. Things can happen at very different paces depending on flow speed and also what mechanism is actually taking hold. This bottom one has much thicker ice, and what happens there is that the top part calves away, reducing the amount of weight pushing down on the seabed, and that causes the edge to lift up and then calve away a large block. That's actually the one that is of greatest concern for Thwaites because the thickness is more like 1 kilometer thick. And this sort of dual action where you lose the top part of the ice and then the bottom part lifts off and breaks off was of great concern. But what this modeling study showed was that those blocks of ice that are out in front and conveniently moved quickly away from the front of the ice sheet, they don't always do that. And if they pile up in front of that calving front, it can slow down the process tremendously. There's also a narrow range of flow speed and ice thickness that really allows the process to be a true runaway. And that doesn't happen very often in models of Thwaites retreat. Next slide. We used hot water drilling to get through the ice shelf and install several instruments that were close to the grounding line of Thwaites. but still in the ocean cavity. Hot water drilling is really remarkable. It does take a lot of equipment. Those are pumps and heaters that you see in the upper right. And then that water jet going into the ice, that hole eventually went 600 meters through solid ice and into the ocean below. And it did that in about 48 hours. So incredibly fast. You can't recover a core. You've melted the core out, but you can install instruments quite quickly or collect a sediment core from the seabed, which we also did at these two sites where we did the hot water drilling. And collected some fantastic information when we lowered a torpedo-like AUV through the hole and actually inspected the area where the ice goes afloat, the exact point where it lifts off the ground. Only one point along a 70-mile coast, but we learned a lot about what controls the rate of melting and how meltwater under certain geometric conditions can insulate the bottom of the ice shelf. So there are probably episodic periods where we see this rapid melting, and then a lot of periods where, because of a cold, fresher water layer near the ice, it's actually protected from further melting. So in the area that we were at, with this geometry, where the bedrock is actually sloping upward as you go towards the center of the continent, that's not the case everywhere. You can actually restabilize the melt loss. But if you imagine what the situation would be if that brown area at the bottom, the bedrock, were tilted in the opposite direction, in fact, you'd have a kind of a pump system working where the water would just keep cycling underneath there, touch the ice underneath, begin to melt, and then the fresh water would be would flow upward on the underside of the ice and away and allow the erosion to continue. So we learned a lot about this. It was a major paper in science, actually 2 papers in science back to back. I said that the loss of the ice shelf wouldn't cause much acceleration. Red means acceleration, but that's the western part, not the ice shelf part. Blue actually means deceleration if you lose the ice shelf. And in fact, that's what's likely to happen initially, although in the long term, you get an increase of about 10% of the ice flow. In order to really see Thwaites run away now, without the ice cliff failure, but the marine ice sheet instability, retreat is going to have to proceed around basically that blue area from either side, sort of do an end around this line of hills that's blocking the outflow from that part of Thwaites. But in about 30 to 50 years, we may see a sudden increase in the net outflow due to this marine ice sheet instability that Hilmar Gudmundsson has been modeling several different ways. Field teams in the Antarctic. This is not near Thwaites. Those magnificent mountains are part of the Antarctic Peninsula. Field teams, as you can well imagine, are extremely isolated, and it's a fairly small group of people. And being able to function well, being able to have a team that really gets all of their work done and stays not just motivated, but active. There's a lot of stress on a team, and I'm going to let Leilani talk about this. But in fact, if you think about it, being cooped up in a few tents with 6 of your closest strangers for weeks on end, closer than a family, every meal, every action, every instrument breakdown, every difficulty or every success, you're together for all of those. And if there are folks that you don't get along with, it can be a real problem for a team. So we've invested a lot with Leilani's help on addressing field team health in Thwaites. And Leilani, take over.
Sure. Well, I wanted to say we will have time for questions, so I'll just make this piece quick. I do want to say that if you think about the dynamics now of teams and go back during the Jim Crow era in 1940 and 1941, you can imagine having a few Black men on a ship expected to mingle and work together in a time when it was segregation. Just another shout out to Admiral Byrd and Captain Cruzen, who made sure that everyone on board felt welcomed. And my father became a civic leader, a community leader, because of how he was treated during the Jim Crow era, during segregation. So that's part of the connection that Ted and I had, was talking about, okay, so the conflict does not go away. The intensity of working together with people that you don't know is still an issue. We may not have segregation, and there's certain expectations of getting along, but some of that still remains. So what we did at Thwaites was think about, how do we have a inclusive field environment? How do we build that? How do we maintain that? And these are some of the things. So, you know, we have a survey pre and post to ask people how they felt and thought about it. We also look at, you know, what the values are and what agreements that we can make. And then part of my work was dealing with the conflict and stress of, so what happens when we have values and a code of conduct, but somebody breaks them, or we can't keep up because things are changing so quickly. So how do we how are we resilient in the face of things that are unexpected? And then looking at the kinds of diversity we have now, checking in daily, having people understand that it's exhausting. So if you're tired, to speak up, and also know that if you've rested for a month or 6 weeks, and all of a sudden there's 2 weeks to get everything done you thought you wanted to do in 8 weeks, that we work kind of round the clock, and people figure that out. But that isn't always easy as well. So this we can talk about for another time, but part of the interest and part of what's in the book is thinking about the Antarctic Treaty. And what I say about this is the world came together in 1959, and Admiral Byrd was also instrumental in that vision. The world came together. Now a lot of more countries have joined, and we can come together again if we have a common vision and we have the political will to do that. There are plenty of issues on the planet we still need to deal with. So I'm going to stop there and see what questions we have.
Okay, well, first, a virtual round of applause. This has been a great talk. This fascinating stuff from